very happy that you click on this video for your Waec Practical Chemistry, and it is a privilege for me to appear on your screen. Therefore, I really want to thank you for doing that, and I will urge you that you watch this video to the end. There are so many things I want to expose to you on this. According to what Waec provided for us, they asked us to make use of two salts. One is ammonium carbonate and copper 2 sulfate, and according to the instruction, they asked us to mix this together with equal mass. That is 1:1 ratio. Now, if the mass here is 1 gram, this should also be 1 gram. If this is 2 grams, this should also be 2 grams. But if you look at the molar mass of this and molar mass of this, each of them differs. And from the equation, as you can see on the screen, you will notice that if you are looking at the stoichiometry of the reaction between this and this, we're supposed to have this to be in the form of 1:1 by mole ratio. If we have it that, we're going to have our answer to give us ammonium sulfate and copper carbonate. It's a double decomposition reaction we are expecting, even though that might not actually be what we are going to notice in the reaction. Yes, it might not actually come over. Because this ammonium, when you react with this normally in equal mole, it's supposed to give us a colorless solution and a pale blue solution. That is, the pale blue will come from the copper 2 carbonate formed, and the colorless will come from the ammonium sulfate. But when you do this practical, you are not going to see that, and there is a reason for it. That is why if you look at the molar mass of this, it's going to give us 96, and the molar mass of this will give us 159.5. But if you look closely to this chemical, you will notice that the molar mass they are writing here is 157.13, and the molar mass they are writing here is 249. My molar mass is 96 here, and here we are having 159.5. Then what happened? This is because this salt, the chemical they produce for us on this salt, mostly comes as hydrated salt, and here it is 5 water of crystallization. Whereas this one also comes with a different substance, an organic substance that looks more like ammonia. You determine that this has some impurity. If you check 96 by 157, it will give us at least 61%, and this one is giving us 64%. Therefore, if we are actually using 1 gram here, 1 gram here, we can still work for it. But the problem is that if we are using 1 gram of this against 1 gram of this, it means that this is going to be in excess based on the stoichiometric chemistry reaction of the two by normal decomposition reaction. But that is not what we're going to have. And I know you may be having problem with, am I going to use how am I going to measure this? To be frank with you, you can actually do this without even using measurements. We can just use our spatula full. A spatula full of this against a spatula full of this can do the work we want to do, and that is what I'm going to use. There's no need of making use of the weighing balance to do this, but you can still make use of the weighing balance if that is what you want to go for. But no matter how you go for the weight balance, you are still not going to be all that accurate as you expected. Therefore, I'm going to make up 1 spatula full of this, also 1 spatula full of this. That is what I am doing here. Okay. Okay, actually I shouldn't use this on this, but because I am looking for exact mass, I'm going to still use this. Okay, if you look at this, the color of this salt is blue, even though not the royal blue compared with this. Hope you got that. Okay, now I'm going to mix these two salts together. Mixing them together, I'm no longer making use of this. I need to remove this from the screen. And if you are a student, this is actually what you are going to be given as sample C in your practical. This is what you're going to be given as your sample C in your practical. And I believe if you follow this to the end, you will understand what you're going to do. They're going to ask you to carry out some exercises on this. I have already prepared possible questions they are going to ask you to do. Now, your teacher might present this sort in this form for you, or maybe as we continue watching this, towards ending of this, because I'm not going to make use of all this. Towards ending of this will start to react with this, because remember I told you before that this has water of crystallization, and that is the copper. The copper sulfate has water of crystallization, and it is a fluorescent. And if you leave it for a longer time, it's going to be evolving water. And when it evolves water, it's supposed to be reacting with this ammonium carbonate. You know, the reaction will start. If at the end of this video we notice that, that's good. If you do not notice it, there is no problem. But here there are possible command words we are going to receive from Waec. Let me pick up my work here. I have some possible commands they are going to give you. The question can be in this form. C is a mixture of two inorganic salts. Perform the following exercises on C. Record your observation and identify any gases involved. State the conclusion you draw from the result of each test. That is the inferences. You need to make the inferences. Mind you, the table will be drawn for you. Yes, Waec and NECO have made it now easier, simpler for us, where they will draw the table for us, just ask us to fill the fonts. Here, they require a quick short answers. So we will try as possible to make use of shorter handwritings to give out our information. And the next command they are going to give you, according to what I have here, is dissolve all of C in about 10 centimeter cube of distilled water. Okay, this is my distilled water here. Stir the resulting solution thoroughly. Keep both the filtrate and the residue. This will tell you that they know that the salt, either when mixed or when dissolved in water, we are going to have a filtrate and we're also going to have a residue. What we mean by that is that we're going to have a solution and one insoluble. That is what they mean by this statement. Therefore, despite the instruction that I should dissolve all, I'm not going to dissolve all, because there's something I am expecting to see at the end of this qualitative analysis. Therefore, let me just make use of only one full of this. I'm going to put it into my test tube. Okay, let me bring in my test tube rags so you can be able to watch what I am doing perfectly. Okay, this is my test tube rag. I'm going to use this. Okay, I want to make sure that you are seeing this perfectly, each and every one of the test tube rag. Remember that this is the I'm using for this work. Okay, now they say about 10 centimeter cube. That means that anything about that 10 centimeter can work for us. Therefore, I add this here. Okay, if you can look closely, you will see a possible reaction happening. There is a possible reaction happening. There is a foaming. Okay. Okay, as you can see, we have two layers of this. We have two layers. We have two layers. One is showing a pale blue, and the other is showing a deep blue. And we really need to, according to the instruction they gave us, they asked us to filtrate. That means we are going to have a filtrate and also going to have a residue. Now I'm going to use this to get my filtrate and the residue, and this serves as the beginning of it. This is a filter paper. I'll fold it like this. Fold it at angle 180, then fold it again at angle 90. Then I will look inside this place, the one that has hole but covered. I'm going to pick one of it. Then pick up my funnel, add here, join it together. See, it does not have any hole, it is closed. Therefore, I'm going to pick up this, pour inside here. Although the color generally gave us a pale blue foams, that's what it gave us here. We are going to wait for this reaction, this physical separation to occur. I am adding a little of this in order to rinse this. As I'm adding a little of water here. Okay, I'm going to leave this for us to have it as a color. In reality, it will take you up to 5 minutes for the filtrate to be removed from this. But I am not going to wait for all the filtrate to be removed before I carry out the chemical reaction. And even in your exam, you can still do the same. There's no need of you waiting for all the filtrate, that is this that is coming down from this, to all come down before you do anything. Also, at the same time, you can notice that the color of this is also changing from what it was. I believe by the end of this practical, the color of this will really change. Okay, if you notice, we are having some good work coming down here. Some good work coming down here. You can see the color. See the color is coming out gradually, and this is showing a deep blue solution. But if you look at what I said in my introduction of this, I said that it's supposed to give us a colorless solution and a pale blue solution. This is the pale blue, but here it is not giving us a colorless solution. It rather giving us a deep royal blue, a deep blue solution. Then the question might be, why is it giving us a deep blue solution rather than what I just said before now, a colorless solution? The reason is because we use excess of ammonium carbonate, and in using excess of ammonium means that the ammonium by mole will first of all react with the copper and give us colorless ammonium sulfate and the pale blue of this. Yet the excess of it is still going to be divided into two. You are going to have ammonium hydroxide and hydrogen thiazocarbonate, that is thiazocarbonate acid. Now this thiazocarbonate acid will be in the solution. The aqueous ammonia is going to react again with the copper, giving us tetramine copper 2 solution. Where this solution will have so many ions inside it, as you can see on the screen as I listed over there. We will have something like thiazocarbonate 4 acid. We're also going to have ammonium tetraoxosulfate 6. We are still going to have copper, tetramine copper 2 sulfate, tetramine copper 2 carbonate inside this. By carrying out the exercises you're going to carry out, you're going to confirm what I am saying about this. And I'm going to tell you the one I believe Waec will focus on, which I believe Waec will focus on the residue rather than the solution, because the solution is going to give us many ions, not just radicals, that is the negative radicals, also going to give us something like ammonium ions, also going to give us copper ion. Both here we are going to have copper ion and also going to have copper ion. And if you are a teacher, or if you are a good chemistry student that have been following your teacher all this while, you normally understand that when you add ammonia to a salt and you have a pale blue, and when you add excess of that ammonia and you have a deep blue solution, it means that that salt contains copper, and that's the confirmation for copper. Now, if we have mixed ammonium and copper and we are having a deep blue solution, it means that there is excess ammonium carbonate in this work. Therefore, I have already gotten some quantity of my solution. I can make use of it. Therefore, in order for me to continue, I will take this and put it here to keep on giving me more of the solution. Here I'm going to separate this into four. According to what I have here, they say divide the filtrate into 2 portions, but I'm going to separate it into 4 because I have things I need to prove for you. And you can notice here this is also changing. I told you that this is going to change. Okay, we go. Now we are going to carry out some chemical tests. We're going to carry out some chemical tests on each of these that I have added here. When we carry out that test, we are going to have our possible answer. I will write the possible answers on the screen, both the tests, observation, and inferences. Okay, they say divide the filtrate into 2 portions. I'm using 2 portions, but I'm still going to do it over 2 portions because I'm having 4 portions here. They say to the first portion, this is our first portion here. Watch, to the first portion, add sodium hydroxide and heat. Okay, I'm not going to make use of heat here. The reason why I will not make use of heat is if I make use of heat, I am the one that is going to perceive the odor. You are watching the video, there's no need, there's no effect. But when you are in the practical ground, you can heat with a boiling tube and not a test tube. Okay, therefore I am only going to do what they asked me to do to demonstrate it. I'm also going to show you how the color will look like, and when you heat it, how it is going to look like. Okay, I'm having my sodium hydroxide here. They ask I need to add it in drop and heat. I need to add and heat. I am not going to heat as I said here. Okay, what I'm going to do is that I'm going to introduce some of my sodium hydroxide pellet inside this. We are going to watch what will happen. The sodium hydroxide pellet. The reason why I'm using this rather than heat is because it's just simple. It's a simple idea that this thing is exothermic reaction when it dissolves in water. Let's see the possible thing we are going to notice if, for instance, they ask us to heat this. Just watch. Let's see. Check the color. You check the color here. You notice that the color here is deep, but this one is becoming pale. It's becoming pale. Okay. This is actually telling us something, that copper is present here, but there's still something that is going to happen here. Let's wait for this to get down. Even when you heat it, it will still take time before you notice the reaction occurring. And if you bring it close to your nose, as I just did now, it's going to be a choking gas coming out, proving that ammonia is present. I don't know if you can see that the reaction has actually started. The reaction has actually started. Because when I touch this, it's now hot. It's very, very hot. Just the same way of using your heater, whether it is your burning, your gas, your burner, or your gas, is going to. Now, if you test, if you try to smell this, you're going to perceive a choking smell gas. Now, if, for instance, I bring my litmus paper close to this, I'm going to get a color change. Expecting to get a color change. This was red and it become blue. This was red and it become blue. This has been blue. Okay? This is blue. this is blue. That means that there is, you're going to have it as evolution of a colorless gas. That is what I have here, with choking smell, turns moist litmus blue. White fumes with rod deep with hydrochloric acid. Now in your inference is going to have ammonia evolved from ammonium present, as you can see on the screen. Remember that the first one has to do with added with water, as you saw in that is the first statement. This is the second statement. The third statement goes like this: to the second portion, see the second portion here. What it asks us to do here is add barium chloride followed by either hydrochloric acid or triazonitrate 5. I'm going to use hydrochloric acid. This is barium chloride, and this is my hydrochloric acid. Now let's add to this. I'm going to have if you look at it, you're going to have a white PPT, that is a white precipitation, and let me add the hydrochloric acid. We still have the white PPT, but there's something I want to tell you. Remember I said earlier that this contain about 4 or 5 ions inside it. This proves that this thing here is sulfate. That means that there is sulfate in this. Do you get me? Okay, but at the same time, there are still some portions of carbonate 4 in this. And for us to prove this, which I believe Waec might not ask this question, but for us to prove that we still have some portions of carbonate present, we need to add HNO3, that is triazonitrate 5, to any of the portion. We are going to have evolution of gas, and this gas turns blue litmus paper to red. I mean the moist blue litmus paper to red, and also turns lime water milky. That is, if for instance they ask you in the filtrate to add HNO3, that means that they are trying to confirm what I said about triazocarbonate being in this solution. Let's add this and watch as there is a change here. That is evolution. That is evolution, and we have a colorless gas here. We have a colorless gas that turns blue litmus paper milky, that turns blue litmus paper red and turns lime water milky, and you can see the change compared to the changes here. Okay, I believe I am done with the filtrate commands. That is what they are going to ask us to do with the filtrate. Now I'm going to keep this. I'm going to bring out the filter paper and make out my residue. It's the residue we want to work on. Yeah, and I believe it's the residue that Waec is actually going to ask you more questions than the other, because it is containing a simple ions, unlike these that are containing more than 2 ions. Hope you get me. Okay, remember here we had a pale yellow. That means that there is copper present here, and also when we heated this thing, we noticed that there is a possibility of ammonia being here. As I say that, when ammonia is coming out, it means that there is ammonium present here, and tetramine copper 2, either sulfate tetramine copper 2 carbonate is also here. Therefore, I believe Waec will not ask much question on this. This is a pale precipitation, is still showing here. Okay, now let's go for, okay, very close. This is the residue. You see the color pale blue, more like this. Okay, now we go, you bring it out, you try to bring it down to that 180 degree. Okay. Now for us to make this thing to work faster, we need to bring a filter paper close. We need to bring a filter paper again, and we are going to go join. Watch what I did. Join like this. Close. What we are trying to do is let the filter paper absorb the water, or in the previous one. Then I'm done with this guy. I'm going to throw it out. Therefore, you can ask your teacher to give you extra filter paper for this. If, for instance, your teacher gave you only one for this practical, okay, I go for the second one. The second one, I'm using 90. Then this is going to be, I place it in this form, okay. Then still divide it into 2. Still divide it again. And what I'm trying to do is make sure that the residue get a little bit dried. That's what I'm doing here. Okay, I can open the residue here for you. You can see the residue here. This is the residue. Okay, we are to work with the residue. Remember that these are the result we had from the filtrate. I'm going to use this place for the result we are going to have in our residue. And you know, our residue supposed to be insoluble. Supposed to be insoluble in water. Let me pick this to the other side so that I will not confuse ourselves over this matter. I hope you can recall everything I have done. Okay, I'm picking this guy out. Okay, picking this guy out. Now let me bring to your notice again about the salt. The color is changing, going towards blue, deep blue. As I said earlier, probably in your exam, this might be the one you will see. If you see this, don't panic. It's the same thing you are going to observe when we are done. Okay, what I'm going to do is I'm going to divide it into 4 portions. According to what I have here, it says divide it into 4 portions and carry out the other exercises. The first exercise is to the first portion, add sodium in drop and in excess. Let's get this. I will divide this into 4. Before that, let me pull this in. I want to pull this in, then add a little drop of water inside it. Remember, I said that it's not going to be soluble. It's not going to be soluble, but you can have some color you can work with. Okay, that's the color we are having. Now let's add sodium hydroxide to this. I hope you can see the color. The sodium hydroxide. This is my sodium hydroxide. Now let's add. There is a pale blue showing. There's a pale blue showing. Let me check if you are seeing it before I. Pale blue precipitation. Watch, you can see the pale blue showing. Now add it in excess to see if it's going to be forming a solution. In excess. Still having the insolubility. That is, the precipitation is still showing. Okay, as you can see on the screen, on what you're going to write as your observation and also what you're going to write as your inference. This is actually telling us copper is here. Remember, I said earlier that copper was also in the filtrate, and also we are also going to have copper in the residue. Now let's go again. The next question I have here is, to the second portion, add barium chloride and follow it with hydrochloric acid, or we can still use triazonitrate 5. It can still work. Okay, let me make this to be perfectly in. Add drops of water. Remember, it's not going to be soluble, we know that, but let's just see something that we can use to react. I'm trying to make sure that it rhymes with one another. Okay, that's the color we have. Now let's add barium chloride. This is our barium chloride here. We add if you look at the barium chloride, actually supposed to give us a white PPT, although it's been affected a bit of the color. Maybe this has not actually gotten it, but when you are filling this form for Waec, it's going to be white PP, but what our eyes is seeing is not all that white, and but we can still feel it. Then the next thing they ask you to fill, to add here, is hydrochloric acid. Let's add the hydrochloric acid. You see, there is evolution of gas when I added the hydrochloric acid. And when you add hydrochloric acid and you are having evolution of gas, this points that there is CO3 2 minus present here, okay, and first one. Therefore, we go for the last portion. The last portion adds us to the third portion. Add hino 3. Okay, this is the third portion I am having. Okay, this is our hino 3. Okay, hino 3. That is evolution of gas, and that gas, as you can see on the screen, what you're going to write as your inference. It is, the practical is partially trickish, to be frank with you. In my thought, my question B1 and C1, my only comment, only 1 out of 8. If you are a teacher, you will notice that the copper 2 ions are present both in the filtrate and the residue, if you can notice that. And despite the balance equation, we thought to occur as a double decomposition, where we're going to have a colorless, and where you're supposed to have a colorless solution and a pale blue precipitate, but that is not actually what we later found out on this. And we confirmed everything I said about this when we had hino 3, that there is CO3 present. Actually, it is a trickish experiment, and what I will tell you is, if you are a teacher, make sure you are close with your students so that they will not panic. And if you are a student, make sure you consult your teacher. But at least, as you can see on the screen, all the possible answers you have to give out, it is there, and you can still see the work over here. Yet in this, we still have the remaining portion. They can ask us to add ammonia in drop and in excess. Let's add this in drop and in excess, see how it is going to look like before I conclude in this video. Okay, let's go in drop and in excess. This is my ammonia. We go. That is a blue. Then if you add it in excess, a blue solution. Now if you look at this, blue solution, that confirms what I was saying in my earlier stage of this video, that this solution we had was actually a partial reaction of the excess of ammonia that is present in each of these videos. Thank you very much for watching this video with me to this extent, and I urge you that you subscribe if actually you are being inspired on what you see over in this video, and make sure you comment, like, and share the links of this video to anyone around you. Thank you very much for doing that.
This is potassium dichromate, and this is the solution. Okay, therefore we are going to have a color change